I have here a soccer ball, and I'm going to drop the soccer ball and bounce it off this table. Here goes. Oh, well, gee, what happened? Well, it's not inflated. In fact, professional soccer balls have a specific amount of inflation that they're allowed to be. In other words, it has to be very, very specific. Can't have one that does that. Nobody would score. So what is it that we look at? We look at some balls bounce high. Others maybe not so much. What we do is we look at something called the coefficient of restitution. In any time in a collision, there's going to be some energy lost from the ball. You can actually hear that as sound. So some energy is lost during any type of collision. You hear it. Now what we do is we aren't really interested in that energy, though. We're interested in the speed. So we take a look at coefficient of restitution. It's defined as being the speed after the bounce divided by the speed before that bounce. Okay? So what you're going to do is on your tracker software, where you're going to take 4 videos of the 3 objects bouncing off any surface. Any surface. Be sure to include some object of known length in your video. Bounce. And you want to get at least 2 bounces. You want to get at least 2 bounces of each object. Okay? Now, come closer. Make sure you can see that. Okay. So on your tracker software, you're going to have use the manual tracker at the position, and your vertical position versus time should look like this. Bounce, bounce, with at least 2 bounces. Okay. Now, if we take a look at this particular bounce, we want to find out the coefficient of restitution. We can get a measurement of that. We're going to do it by using the definition, which is the velocity before and the velocity after. So the coefficient of restitution is defined as being the velocity after divided by the velocity before. You can think of it as the percent of speed that was maintained after the collision. Now, if we neglect air friction and energy is conserved everywhere else but the bounce, then this would also equal to the square root of the max height that it bounced to divided by the height it started with. And of course, then each successive time, the height would get lower. So we have 2 different ways of calculating this. One is using velocities, the other is using the heights. Your task for this is to make 4 videos of the 3 balls that we give you on any given surface. It could be any surface, it just needs to be the same surface. It could be the table, could be the floor, could be the stove. Do please choose something where it actually kind of bounces. I don't think a sandbox is going to really work here for us. And then a 4th video where you take any of the 3 balls, and do it on some different surface. Could be another table, not made of the same thing. Could be a countertop, whatever. So those are the 4 videos that you're going to take. We'll be posting up a video on how to analyze those using the tracker software. And we'll see you then.